In this video I want to explain to you some of the things that you'll need to know to be able to write and interpret chemical reactions. These are the types of questions that you were encountering on assignment number 1, which in a later video I'll do some of the problems from assignment 1, but also information that you'll need for future assignments. This has to do with writing, interpreting, and being able to eventually balance chemical equations. And chemical equations are kind of the key to being able to interpret what's happening in a reaction and eventually later to be able to solve for specific amounts of reactants and products that are used and formed in any chemical reaction. So a chemical reaction needs to be written with information that tells somebody what reactants, the original materials that were used in the reaction, are combining to form specific products, the final result of that reaction. And the chemical equation has information in it. As you see, it lists the reactants and the products to the left and right side of the arrow in the reaction, as well as some information that's in numbers, the coefficients, which are the number of molecules of that specific reactant or product, as well as subscripts found in the formulas, which are identifying the numbers of those specific elements in the formula. So a chemical reaction is showing the process of how reactants become products and the numbers of each reactant and product that are formed in a reaction. To write and eventually balance a chemical equation, you'll need to use some of the sheets that you have from previous units. So if you have your periodic table and your oxidation sheet, you might want to take those out to follow along with what we're going to be doing and where to find information on those sheets. So let's get started. One of the first things that you might be asked to do is interpret an explanation for a reaction and get that information from the word explanation into a formula equation. For example, this reaction involves solid potassium and a solution of lead 2 nitrate reacting to form the product of a dissolved potassium nitrate solution and solid lead. We can turn the names of things from the reaction into formulas by looking at some clues of information that are provided in each of the names. One of the first things that you can look for is the length of the name and whether it's a one-worded name or a two-worded name, and what that means about each of the objects. For anything that was a one-word name, most of those are just elements that are found on the periodic table. So the most helpful sheet that you have is the periodic table, and the formula or symbol for what you're writing just comes off the periodic table. There is an exception to certain things that are considered special elements, and you'll find a list of special elements on your oxidation sheet. So anytime you read about the name of these special elements, you'll write the formula that you see or find on the special element section of your oxidation sheet. For example, if a reaction is involving hydrogen, instead of just writing H for the formula, you would write it as H2. Same with nitrogen, oxygen, fluorine, chlorine, and bromine. For phosphorus, you'd write P4, and for sulfur, S8. Now other times there's one-word names that you're going to encounter that aren't elements on the periodic table, but should be common sense when you read about them, or in the future as you see more and more of these in examples will become common sense. But one-word names like water, or alternative versions of it like steam and ice, aren't elements, but most of us know the formula for water. And another one that you'll encounter quite often is methane, and that name is describing a chemical compound, CH4. So as you start seeing more and more examples of things, some of those common sense names and formulas for them will become more familiar. So for any one-word name, most of the time use your periodic table, look for the element on the periodic table, and check whether it's a special element. If it's not, just write the symbol for that element as you see it on the periodic table, or if it is a special element, use the element or the formula off that special element list. For two-word names, we assume the object's a compound, and how we wrote the formula for compounds depended on whether it fell into the category of ionic or covalent. And so there's clues to the names of things that are compounds that'll identify whether it falls into either of those categories. The first is the ionic category, and ionic compounds can be either binary ionic, polyatomic, or acid. And there are things about the names that we should be able to identify that classify whether they're in any of these categories. One is how a name begins. Some formulas have prefixes, some don't. So if you don't see prefixes on the name, it falls into this category. Also how the name ends, put it into a specific location, like the ionics that end in "ide", polyatomics that end in "ate" or "ite", and the acids that names end in "us" or "ic". So if you ever encounter a name with no prefixes and any of these endings, it falls into the ionic category. And for any ionic formula, we use the oxidation sheet to look up and grid swap our formula. And so this is something that hopefully you've done in several examples from previous units. And so get out your oxidation sheet, grid swap, reduce, remove. Now if the word acid is attached to a name, there's also something on your oxidation sheet on the back. You can find the acid list, which already has listed a bunch of the common acids and their formulas. So if a reaction involves a specific acid, rather than using the oxidation sheet to look up the ions involved, you can go straight to your acid list and just look up the formulas off the acid list. If the name you're reading does have prefixes on either name, that could be a prefix on the first name or the second name, or sometimes both names, that puts the compound in the covalent category. Now for covalent compounds, we didn't use the oxidation sheet or look up ions to grid swap the formulas. And so really all you need for covalent compounds is your periodic table if you need to remind yourself of the symbols for either of the elements involved. But the information for numbers in the formula are just described by the prefix in the name. So carbon dioxide is just the formula, 1 carbon and 2 oxygens, or CO2, directly interpreted from the name.